Hi everybody, this is Mrs. Dunn. In this section we're going to talk about LionTeef input-output analysis. This is a really cool application of matrices and inverses, especially if you're a business major. Okay, so first of all, the word is LionTeef, and it comes from the name of the mathematician who he received a Nobel Prize in economics for his study of this input-output analysis. It's a direct application to the business field. So let me give you an example. So consider this. We have an economy which is based on two industrial sectors, coal and steel. Production of $1 worth of coal requires an input of 10 cents from the coal sector and 20 cents from the steel sector. Production of $1 worth of steel requires an input of 20 cents from the coal sector and 40 cents from the steel sector. Find the output for each sector that is needed to satisfy a final demand of $20 billion for coal and $10 billion for steel. So first of all, what we're doing here is we're looking at how these two industries, these two industrial sectors are related to each other. You see how to create $1 worth of coal, it requires coal. And to create $1 worth of steel requires some steel. So these sectors are all interrelated. So first of all, I want to look at this last sentence and I want to talk about what's the final demand. Well, the final demand is we need $20 billion worth of coal. So we're going to need more than $20 billion worth of coal because we're going to be using some of that coal to produce $20 billion worth of coal. I hope you followed that. And we're going to need $10 billion worth of steel. So what this question is asking is how much coal and steel is required to meet that final demand? Well, we're going to use this variable x1 to represent the total output of coal and x2 to represent the total output of steel. So from that, I've created two equations. The total output of coal requires like $1 worth of an output of coal requires 10 cents from coal and 20 cents from steel. And $1 worth of steel requires 20 cents from coal and 40 cents from steel. This I can find in this in the problem restrictions that were read to you. Look at what it says. A production of $1 worth of coal requires an input of 10 cents from coal and 20 cents from steel. That's where this equation came from. And same for this. 20 cents from coal, 40 cents from steel. Okay, well, the total output is going to require this internal demand, which is right here, plus the final demand, which is right here. So now we want to take into account this final demand. So that means that our total output is going to require 10 cents from coal, 20 cents from steel, plus the amount that we need for that final demand. And same for the second equation. Okay, now here's all that information that we have. Now, how does this apply to matrices? So all of this is going to help us with our the information we learned in the previous sections is going to help us with this. All of what we have learned about matrices. So what we're going to do is we're going to create a technology matrix. So that technology matrix is going to talk about the coal and the steel. I've labeled the columns C and S for coal and steel, and I've labeled the rows C and S for coal and steel. And I've created a matrix. So this is that idea of an input and an output. So the input is coming here from the left. The output is going up. So you look at this and you read that to produce an output of $1 worth of coal, we need an input of 10 cents worth of coal. To produce an output of $1 worth of coal, we need an input of 20 cents of steel. So if you look down this column represents just this part. Remember that internal demand of 10 cents for coal and 20 cents of steel. So every dollar's worth of coal requires 10 cents from coal, 20 cents from steel. That's written right here, not the row, it's this column. Same with an output of $1 worth of steel. It requires 20 cents from coal, that's written here, and 40 cents from steel, that's written here. Okay, now, this is what we learned in previous sections. We're going to write this whole equation using matrices. So X, remember, is our coefficient matrix, which is X1, X2. That's going to be that total output of coal and steel. M is our technology matrix. This is X again. And D is our demand matrix. So the demand matrix, remember, is this 2 by 1. $20 billion for coal, $10 billion for steel. Okay, and then we use these matrix operations to solve this matrix equation. Remember, first we're going to subtract mx from both sides of the equation, and then we're going to factor out the x, and then we're going to multiply both sides by the inverse of I minus m. Now, you're not going to have to do this every single time. It's just this equation right here, which is the most important. I wrote it on the next screen. So this is what you want to remember, and this is the equation you're going to solve for every problem in this section. So to find that total output, we just have to put these matrices in our calculator and solve. So I just showed you, because I don't want to take the time to type it in here. We've learned that in the previous sections. But I labeled my matrix I, my identity matrix. And so my identity matrix is a 2 by 2 because our technology matrix is a 2 by 2. I didn't have an M for the matrix, so I put that in letter A. So you can think of this A as an M. And so this is our technology matrix. And D is our demand matrix, which is this 2 by 1, 20 billion for coal, 10 billion for steel. And then I simply type that in my calculator. So using parentheses and the inverse button, I did the matrix equation, and the answer comes out to this 2 by 1 matrix, which is 28 and 26. And that means X1 equals 28, X2 equals 26. So the output required is $28 billion for coal and $26 billion for steel. Okay, now this was a 2-industry model. Let's look at the same problem with 3 industries. So I'll pause the video and allow you to read the problem. Okay, so now let's look at that. If you need a little bit more time, pause it, read through it. And what I'd like you to do is I'd like you to identify what is the final demand required. So the demand that is required is $20 billion for agriculture, $10 billion for energy, and $30 billion for manufacturing. What are we being asked for? How much output in agriculture, energy, and manufacturing is required to meet this final demand? The first thing you're going to need to do is create that technology matrix. Let's do that together. So I've labeled my technology matrix. The columns are labeled A, E, and M. A for agriculture, E for energy, M for manufacturing. Now remember, it's how much agriculture is required to create $1 worth of agriculture? Well, we're going to read that from the problem. A production of $1 worth of agriculture requires an input of 20 cents from agriculture, 40 cents from energy. It only mentions agriculture and energy here. There's no mention of anything from manufacturing needed to produce $1 worth of agriculture. So look at how that got interpreted in the technology matrix. We need 20 cents from agriculture, we need 40 cents from energy, and nothing from manufacturing to create $1 worth of agriculture. Look at the next sentence. A production of $1 worth of energy requires an input of 20 cents from energy and 40 cents from manufacturing. So energy requires no agriculture, 20 cents from energy, 40 cents from manufacturing. Look at the third line. Production of $1 worth of manufacturing requires 10 cents from agriculture, 10 cents from energy, and 30 cents from manufacturing. 10 cents from agriculture, 10 cents from energy, 30 cents from manufacturing. Okay, we're going to use that same equation. To save some time, I'll just show you. I put those in my calculator. So you'll see how I put the identity matrix now as a 3 by 3. Why? Because our technology matrix is a 3 by 3. So here we have all of the matrices put in there. Remember, our demand matrix is a 3 by 1. And when I type that in my calculator, I get this 3 by 1 matrix, which tells us the total output required is $33 billion from agriculture, $37 billion from energy, and $64 billion from manufacturing. Okay, I hope you enjoy this section. I think it's pretty cool, and definitely you can see how this would be used. All right, email me if you have any questions.